in ISRO, we have a team called NICES, National Action Flows Climate Research and Change. So this is piloted at NRSC Hyderabad, where we make use of various stakeholders who are working in the sector, who are doing research, all the universities, institutions who are part of this climate research are brought under this. And what we do is that we provide information based on the space-based as well as terrestrial sensors that we are deployed. And this data will be put in a platform in our websites. And this data can be downloaded by everyone free of cost and make use of it for their research. So this is the first and foremost action that we do. Then we conduct programs on a regular basis on campaigns to understand various aspects. A few of them I'll tell you. One is we map entire forest land, find out what is the extent of forest land and how much it is very good quality, how much is getting depleted over a period of time, how the boundary changes occur. So this is one information that we give to forest survey departments. We map arid lands of the country and find out whether these areas are becoming greener or they are worse over a period of time. We map entire water bodies in the country. There are lakhs of water bodies in our country. All of them are mapped with regard to the water content and how it cyclically changes with the season, whether water will come and go down, the quality of the water, whether it is suitable for fish cultivation or otherwise, this type of information that we give. We map entire rivers, looks at the outage, the pollution, how much water goes into sea, the flooding patterns, in seasonal flooding patterns, and its prediction of inundation. We look at all the glaciers, and there are lakhs of glaciers, and all of them are mapped in such a manner that and we give the quantity of ice and how it changes with cycle, how it increases or decreases over periods of time. We measure atmosphere around Indian continent and also beyond it, map the entire water content, the clouds, the precipitation, and we also measure the sea surface, the waves, the salinity, the color, and look at how the fish production activity takes place, the producibility of the seas are measured. Like that, we measure essential climate variables. We know about 50 plus are there, out of which certain numbers are monitorable from space. Around 12 to 13 essential climate variables are measured from space, rest are measured from ground measurements, and this data is continuously updated in our websites for all the climate modelers to make use of it. So, and we continue to develop new sensors and new techniques and algorithms. One of the recent one is a GNSS reflectometry, where we use a payload on board the satellite to look at a radar-based observation of the GNSS signal, which comes directly from satellite as well as reflect from Earth. So we can find out how the geophysical parameters influence those signals, and we can make a measurement of various parameters. So new techniques we develop, and this is given to all the scientists working in climate weather modeling free. The first and foremost is being aware of it, is to understand that there is a change happening in climate and weather, which is much faster than it used to be in the past. Because our actions are not towards making it better, but it's actually making it worse. It could be in various ways. The type of exploitation of Earth, the deforestation that is happening, the pollution that is created out of industries and energy usages, and our way of life, it actually creates problem or stressing on the environment. And first, a society must be aware of it. And once you are aware of it, you will be able to take certain actions like not polluting your rivers, not planting more trees, don't remove greeneries across the country. Exploitation natural resources should be in a controlled manner, not over-exploitation for your benefit alone. So there are many things that you can actually do in small scale that will actually reduce the speed at which the climate change occurs. But you cannot eliminate it because it's very natural to happen. And you should also learn how to become adapted to the change and live in such a manner that you will be able to continue to living without getting extinct. Space is one area where you can get interested, but there is a lot of other things possible. I want to always say all of you come to space. Space is a very limited domain where you can actually work in rockets, satellites, or its applications. It's a really exciting domain, but it's those for who have a passion, you can always join. But you can be in any domain but still work for space. So even a material scientist, a climate and weather scientist, or a chemical scientist who works on propulsion, everything is open for space. But today I will offer you that there is so much of things that can be done based on space-based applications. For students here, I would like to advise that there is so much of work that you can do based on the data that comes out of the space missions. Converting the data to a product to become useful by the community is called business. So if you can work out how to convert that data, for example, the points which I mentioned is sequestration and footprint calculation, and every industry is looking for it. And if you can really create an app or a development a useful application which will actually quantify you due to your work how much of footprints are being changed, and that becomes a very important measure of finance even today for companies. I'm giving an idea for converting that idea into a business opportunity. So students can look at it not just technological work, but also converting the result of those technologies into a useful product and create business. Unless you have economic activity around it, our space research capability will not increase.